Hello guys, here we go again looking at a question from a 2016 past paper under the topic circle theorem. Now let us quickly look at the question at hand. The diagram below, not drawn to scale, shows a circle with center O. TAE is a tangent to the circle at point A and angle AOD equals 72 degrees. Now let us quickly put in some of the easily identified angles before start working. If this angle is 72, therefore opposite angles are equal, so this is also 72. Angles meeting at a point sum up to 360 degrees, therefore we can add 72 plus 72, subtract that from 360, and we will get 216. Then we divide 216 by 2, we get 108. Therefore this is 108 and this angle is 108. Now let me quickly erase this. Remember those angles, so let me write them here. 108 and 72. Alright, let me erase these. If BO is a radius and OA is another radius, therefore we are looking at an isosceles triangle. What do we know about an isosceles triangle? If your answer is base angles are equal, these two angles are equal, and these two sides are also equal. Now remember that angle is 108. So we subtract 108 from 180 and we get 72. Now we divide 72 by 2 because these two angles are equal and we get 36. Therefore B is 36 degrees and A is 36 degrees. Now bear those angles in mind. Also let me put that here, 36 degrees B. Now let's erase these and attempt our first question. Calculate, given the reason for each step of your answer, the measure of 1. Angle ADC. Therefore we want to find this angle D. Okay? Now if we look carefully, we'll realize that CA is the diameter. Therefore we'll have a semicircle or two semicircles. Alright? Angles formed in a semicircle or angles subtended in a semicircle measure 90 degrees. So therefore D is 90 degrees. And the reason for that, angles subtended in a semicircle measure 90 degrees. Alright, quickly again, let me erase these so we can see clearly when working. Let us calculate number 2. That's the angle of ACD. So that's ACD. This time we're trying to find this angle, C. Now remember earlier on when we put in some of the measurement, we realized that B was 36 degrees. Now if you look closely, this is a chord. Now, angles form in the same segment. If this is a chord, on this side, we'll have the minor segment, and over on this big side, we'll have the major segment. Now, angles form in the same segment, which is this major segment, are equal. So if B is 36, then C is also 36. Alright, so 36. And the reason angles form in the same segment are equal. Again, let me quickly erase these so we can see exactly what's happening. Now there are two other angles they ask us to find. CAD, that's CAD. So therefore we want to find this angle. Now earlier on we found out that D is 90 and C is 36. So all we need to do now is add 90 and 36, then subtract that from 180 because we know the interior angles of a triangle sum up to 180 degrees. So 90 plus 36 give us, and if your answer is 126, that's correct. Subtract 126 from 180, we're left with, and if your answer is 54, then angle CAD is 54 degrees. Reason: interior angles of a triangle sum up to 180 degrees. Let me quickly erase so we can see clearly. Alright, let's look at the final question. Angle OEA. OEA. Alright, now we found out that O is 72, and if we look closely, let me use another color. OA is a radius. TAE is a tangent. Now, wherever a radius meets a tangent at the point of contact, that angle measures 90 degrees. So again, A is 90 and O is 72. We add 90 and 72 and our answer is 162. Now we subtract 162 from 180, and if your answer is 18, then you are correct. So therefore E equal 18 degrees. And the reason is angles, interior angles in a triangle sum up to 180 degrees. And there goes 8 easy marks. You do enjoy this video. Thanks guys.